learn the lesson that next time around I shouldn't tell what it's really worth to me. Because this other guy only, the most anybody came close to is $1. Why should I tell everybody that I need it as much as $2? So I will say maybe 90 cents. And then I won't get my advertisement. I won't get my eBay item. Okay? Now, an interesting version of doing this, basically, in all these cases, essentially, you are submitting your bids. These are called sealed bid auctions. So you're making your bid and you're telling the auctioneer. And nobody else knows your bid. And similarly, you don't know anybody else's bid. And all you know is what the auctioneer guarantees as to who will get the item and what price they will be charged. A normal idea is first price auction, where the guy who bids the maximum will get it, and they will pay the money they bid for it. Unfortunately, as I said, that does not encourage truthfulness, which means both the advertisers and the search engines would be losing money on the whole. Okay? So there is another idea called Vickrey auction, which is also called second price auction. And the idea there is everybody bids, the guy with the highest bid gets the item, but would only pay the second highest bid. Okay, so in the case, I want it for $2. I bid $2. I submitted my bid as $2 in a sealed envelope. You submitted 50 cents, you submitted 30 cents. I will win. So I will get the item, but I only have to pay 50 cents. This almost looks nonsensical. Why should people be allowed to pay the second bid? But the interesting thing is by doing this, you encourage people to be truthful. Because in essence, what happens is, in game theory, the issue is, there are strategies that you are using. The question is, are there better and worse strategies? Okay? And it turns out that if the mechanism is second price auction or the Vickrey auction, then truthful bidding is a dominant strategy. That means the society and you don't do any better. Actually, you don't do any better. You, the winner, the buyers won't do any better by any other alternative strategy. Okay, now, I don't know how many of you have already heard of second price auctions, but if you haven't and if you're wondering why does this make sense, an insight is think of how cattle auctions go on. I remember the cattle auction, the guy was saying $1, $1, 2 cents, $1, 2 cents, $1, 3 cents, anybody for $1, 3 cents? I am pretty good at this. But the point is, what's the difference between that auction and this auction? There it's non-sealed bid. Everybody's bid is in front of you. So you never tell anybody how much you like this cow. Right? You just sit around there. And then this guy starts with $1, $1, 2 cents, etc. And if the guy starts with let's say $1, who wants $1? And I'll raise my hand. And then if nobody else increases it, even if it actually is worth $100 to me, I only pay $1. If somebody does like it as much as $50, they will keep taking this auction up to 50. Then I will pay 50 plus epsilon and get it. So I'm essentially paying $50. The guy who wins the auction is the guy who added the last epsilon. And so they really are paying only 50. Nobody actually goes to know, unless in movies where this guy says $10 and the next guy says $10 million. Right? Nobody does this in cattle auctions at any rate. Right? It would be a really price-winning cow. But the point is that you are essentially only paying if you know everybody's bid, then you're only paying the value that this cow has for the guy who likes it the second most, not the value you have for the guy that you like. You see what I'm saying? So exactly this is what happens in open. I'll get to you later. There are many questions that you might have. I want to actually get through this point today, and then we can talk a lot more out of the class or later. Okay. If there's a lot of questions next class, I will spend time discussing those too. Okay. So this is worth remembering, that in fact second price is what you do in open price auctions, in essence. And in the sealed bid auctions, you're trying to, if you want to try and simulate the fairness of the open auctions. The problem with the open auctions at the internet scale is everybody has to be available at the same time and should be having those little things that they raise, saying $10, $20 more, etc. It's a very painful process to orchestrate, but it's a fair system. And Vickrey action essentially is making sure that you get as fair a system as that, but with sealed bids. And since in an open action you will never, unless you are again dropped repeatedly on your head, you will never bid more than what that cow is worth to you. If some guy says it's worth $100 to you, some guy says $5,000, you won't suddenly just say, to spite him, I'm going to take it $5,001. That makes no sense. If it's really worth $100 to you, you should keep your mouth shut and wait for the next cow. Right? Okay? So you will always speak your value truthfully, in essence. And you will only pay the second guy's price. This is what you should be using essentially in most auctions. The only question, of course, this is a nice slide explaining why it is the case that truthfulness is a dominant strategy for Vickrey auction. Okay? That means you can't do any worse than being truthful. I'm sorry, you can't do any better than being truthful. Okay? And this guy is Vickrey, and he got a Nobel Prize for this idea. Okay, but he proved it too. What? Economics. Economics is all about multi-agent intelligence. That's what it is. Okay? So, the question, the last thing that I want to talk today is, almost last thing I want to talk today is, you need to generalize this to multiple items. There, the idea is there's one cow at a time, okay, and people are bidding on that cow. Or one item at a time, and people are bidding on that item. Most normal scenarios, you may have multiple items being sold at the same time, and people are submitting their bids to all these items at the same time. So you say, I have all these, advertisement queries I am going to take bids for now. And everybody says, okay, this is my bid for this. And these are, and somebody else gives another check saying these are my bids for these. Okay, so in essence, you have a system like this. Essentially, there are two advertisers and two queries, two fruits. Okay, and then this advertiser is willing to pay $25 for this and $20 for this. This advertiser is willing to pay $20 for this and $30 for this. And it's not one, they are willing to pay all that much. So this guy would like to take both if you give him. And this girl. And this guy will like to take both if you will give him. As long as, you're using their bids. Okay? Once again, the question is, you have to give people a trust in the mechanism that even though they are truly speaking what it is worth to them, that the search engine would not exploit it. I mean, that the auctioneer would not exploit it and sell it to them at the price they bid, but only sell it to them at the price the next highest guy bid, in essence, for the single item. Okay? Now, if you have multiple items, then the question is, how do I generalize this? Now you have like two items and bids for all of them at the same time. There are two related problems. One is allocation. Who gets what? So, who gets the apple, who gets the banana? And then, don't answer the question here. The second is, after I decide who gets what, how much are they paying for it? Okay? Who gets what is easy. Essentially, it's a maximum matching problem. So you have these edges in this graph. Okay? You need to pick a set of edges such that there's exactly one edge on each of the items if possible. Right? And then the sum of their weights is the maximum. Right? Okay? And whoever is getting what item in that matching, that is the person that gets that item in the allocation stage. The second question is, how much are they going to pay? The simplest idea, so in this particular case, I assume you would agree that this Alice would get the apple and Bob will get the banana. Right? That would be the maximal matching. Okay, now the question of course is, how much is Bob going to pay for the banana? How much is Alice going to pay for the apple? Okay, you obviously have heard that there should be this thing about second price. Now the first idea would be to just say, well, look at who else are bidding for the apple. This guy bid, Alice bid 25, this guy is bidding 20. So that's the second highest bid. So Alice will pay second highest bid in the current matching. in the current matching. And similarly, this guy would pay $20 for the banana. Right? Okay. Now, unfortunately, that is called the generalized second price auction, and it does not have the beautiful property that we talked about for the Vickrey auction, where people have to be the truthfulness is the dominant strategy. Okay. To get it right, so basically, I can go from single Vickrey auction to multi-item auction by first doing the matching and deciding who gets what, and then have to decide how the pricing works out. And for the pricing, if I just pick the second highest bidder for each of the items, according to the current matching, that's the easiest thing to do. Unfortunately, it doesn't have the property of the parent, which is truthfulness is a dominant strategy. And I can't even explain to you right now, you should go back and look at it. What does work, and if you think about it a little, you will get it too. Here in this case, it turns out that the other strategy I'm saying will give the same answer. But imagine, if you will, and I'll try to give an example once I go back, there are many, many users, many, many items. What you really want to ask is if Alice is getting the apple, the price that Alice should be paying for the apple should be decided not by who was the second guy who is paying the apple here. That guy may not be getting apple in the. So here's the question. So if Alice was not there, so Alice goes home, takes her bid, 25, and goes home. It's not part of the graph anymore. Now you can still match and see who gets what. And whoever is the first highest bidder for apple in that case, that is the true price of apple if Alice weren't around. Now that as Alice is around, Alice just only has to pay what other people would have paid as the highest price if she wasn't around. Okay? It's a beautiful idea. Think a little bit more about this. Now the way to do this would be that you remove, there's a big graph here, you already matched once, you got the maximum matching and you figured out who gets what. Now I have to decide what is the price of the apple. I remove Alice and the 25 link. I do another max matching. And somebody gets apple. That person may not be this because there may be other people who are bidding for the apple and they may be bidding less than $20 and this guy won't get apple because of some other complication. So in essence, you need to run that matching second time to get the price. That's costly. But if you do that, you get what's called VCG auction or Vickrey, Clark, Groves auction. And that's the general auction. That one has the truth being the dominant, truthfulness being the dominant strategy. Again, a beautiful idea that we just happen to come into because we're thinking of advertising. And the last thing I want to say, and by the way, not surprisingly, this is the right thing to do for users to speak the truth. This is easier to compute. And it also turns out that it actually might sometimes actually increase the revenue for the search engine. And so, not surprisingly, at least according to Google, again, these things are what any search engine does for advertisements is closely guarded secret. When poor Raju did his ranking stuff, he wanted to run it on some data to see that, to actually show that his work is better than what Google is doing. So we sent mails to Google and Yahoo. He got even an award from Yahoo from some other reason. And he said, why don't you share with me your advertising data? And they said, are you crazy? We're not going to give you anything about your advertising data. Even Yahoo won't. And you can imagine Google certainly won't. Right? So, but it is assumed that Google actually uses generalized second price action rather than VCG because that's actually harder to do, although it does good. But if that looks like at the end of the world, it's not, because in fact, what I did today in the class is to look at a bunch of issues, mostly sort of one by one. So I kind of looked at user interest. I took the CTR is the way user interest is taken into account. The user was not clicking, then there's no point in showing this as I took into account search engine interest. I'm looking at the ranking so that people are likely to click. And the budgets, if you don't take the user's budgets, the advertiser's budgets, you may generate less revenue than otherwise. Okay? I also looked at advertisers' interest, because we talked about keyword bidding as against query bidding, and we looked at auctions, which sort of give guarantees to the advertisers that if they are truthful, in fact, the world doesn't end. But unfortunately, in fact, that's if you use VC. Okay? As if they're all sort of independent. But the tricky part is they're all interdependent. Okay? The actual bids depend on what the search engine is doing. So people will change their bids based on what the search engine is doing. The ranking depends on the bids. And so there's a lot more second order issues that I haven't gotten into. And this is the maximum I can do given the scope of this course and given that there are a lot more interesting topics which we have to talk about. Okay? So I'll end here. Okay? If you have questions on this, send me email, talk to me after the class, or we can talk a little